Sobre tu ponte agora. participants. Welcome to our two-day national level faculty development program. I hope you all are doing well. Just to begin with, I'd like to inform all of you that post the session, approximately about 15 minutes before we end the session, we shall be sharing one feedback link, which is also your attendance link for the day, requesting you all to kindly fill that up and also be present for the session tomorrow, and only then will you be entitled for the certificate of participation. Okay, so please look out for the link that will be shared with you towards the end of the session. Okay, as the filling up of that is mandatory and is important. We hope you take back a lot of learning from this entire session, from this entire FDP that we have planned for you, and we hope you make the most. Once again, a very warm welcome, and we will begin at sharp 3 p.m. Thank you once again for joining us. A very warm welcome to each one of you. I hope you all are geared up for our 2 day National Faculty Development Program and are excited as we are. We shall be starting at 3 p.m. Just a soft reminder to all of you that towards the end of our day one, we shall be sharing one feedback link, which is mandatory for all of you to fill in, as that will also work as your attendance link. This will enable us to track your attendance in terms of having your certificate being sent to you. So it is mandatory for you to attend both the sessions on both the days, that is today and tomorrow, in order to get your certificate. And also a soft appeal to all of you. It would be great if you keep your cameras on, as that will facilitate better interaction with the resource person and with all the participants out there. So once again, a very warm welcome to all of you, and we shall be beginning at precise 3 p.m. Thank you again for joining us, and we hope you have lovely learning coming your way today and tomorrow. Thank you again. Questions that you have for a resource person while the FDP is on, while the session is on, please feel free to use the chat box and post your queries in there. Towards the end, our resource person will address all your questions. All right, so please do make a use of the chat box and please do put in your queries in there. Thank you once again. A very good afternoon, participants. My name is Rohit Ramurthy, and I take this opportunity to welcome you all to our two-day national level FDP on data analysis using SPSS, AMOS, and R, organized by the Research Cell, Center for Management Studies, Jain deemed to be University, Bengaluru. It is a moment of pride to announce that Jain deemed to be University has secured an 85th rank by the NIRF ranking conferred by the Ministry of Education, Government of India. Center for Management Studies is an integral part of Jain deemed to be University and is an institute that harnesses an international outlook with the commitment to create top-notch business leaders of the corporate world. The corporate BBA and BBA WOW program at Center for Management Studies, Jain deemed to be University, provides its students with a solid foundation in business and management through the flexibility to specialize in the area of their interest. The programs have been designed to maximize students' experience and networking opportunities in business and to help them get hands-on experience with the industry and the changing economy by giving them a competitive edge to deal with the real world challenges. The entrepreneurship program of CMS has been designed to ignite creativity in students and encourage their resolving skills to pursue their own ideas. The academic practices of CMS empower students to redefine conventional wisdom and business perspectives and are committed to train budding business leaders and aspiring media professionals. CMS, Jain deemed to be University, has secured an A grade by the National Assessment and Accreditation Council with a CGPA of 3.31. We are ranked among 16 top 50 colleges in India and highest for academic excellence with a score of 197.8 by India Today and rated A plus at state level and A at national level by CRISIL 2019. CMS is an ultimate destination for students where they can find new avenues to fulfill their dreams. I now request our respected HOD, Professor Sunita BK, to address and welcome the participants.
Thank you, Rohit. Thank you so much. Good afternoon, each and every one of you. Due to some university commitment, our director cannot be there today. But at outset, I would like to thank our President, Dr. Chandra Roychand, our Vice Chancellor, Register Sir, Pro Vice Chancellors, and all the principal officers of the university for encouraging us to conduct this event. Above all, we thank sincere thanks for our director, sir, who always supported any endeavor of us in anything we do, absolutely anything we do, and the liberty and the independence he gives us to conduct such programs. And last but not the least, I'd like to thank all the participants for joining us in this learning process. It's indeed an honor for Jain deemed to be University Center for Management Studies to host you today. I would also like to thank Dr. Varsha Agarwal and Professor Srinidhi, who are going to share their valuable knowledge with all of us. Not to praise both of them just because they are my colleagues and friends, but I would also like to place on records that both of them are extremely talented in the field what they are going to exhibit today. Thank you so much, Varsha. Thank you, Srinidhi, for agreeing to do this FDP to all of us. Thank you so much.
Thank you so much, ma'am. My dear participants, once again, a warm welcome to you all, and we sincerely hope that you are keeping safe in these unprecedented times, and so is your family. All right, so before we begin, I'd like to introduce the speaker for today, Dr. Varsha Agarwal. Dr. Varsha Agarwal presently works as an assistant professor and research cell coordinator at the Center for Management Studies, Jain deemed to be University, Bengaluru. She has more than 7 years of academic and research experience. She completed her MBA in finance and marketing from ICFI Business School, Gurugram. She pursued her PhD in the field of healthcare quality from Christ University, Bengaluru. She has gained advanced level proficiency in research data analysis software like SPSS, AMOS, and R, and has delivered sessions in many national and international level workshops. She's been a part of several FDPs and has hosted many webinars for faculties and also for PG and UG students. She's certified for data analysis skills from Harvard University and Johns Hopkins University, USA. She has published 2 books and 38 papers so far in many national, international, reputed, and Scopus Index journals, including Emerald and Sage. She's had the opportunity to present many papers at various prestigious institutions such as IMA, IMB, and IMK. She has also won several accolades and awards for her best paper. A heartfelt welcome to you, ma'am. Thank you so much for taking your time and consideration this afternoon. Now it's over to you.
Thank you, Rohit. Thank you, Sunita, ma'am. So without a further delay, we will start with today's session. As you know, today's session we have divided into 2 parts. The first half I'll be taking on SPSS, and the second one will be on AMOS structural equation modeling. In both the sessions, first I'll be covering the introductory theory, and then we go for the practical aspect. And tomorrow, as you know, that we are going to cover about the R programming. So I'll just share my screen. Okay. So in today's session, we are going to cover about theoretical background, a little bit about SPSS, how any SPSS file looks like, and how do we test our hypothesis, how do we make graphs, charts using SPSS easily, and how do we conduct chi-square test for looking out association between variables without even thinking about much about their correlation or regression, just to know that whether they're associated or not. And then in the end, we will also discuss about factor analysis, correlation, and regression. So in the entire thing, what happens actually, why we have chosen it, because these are the test or analysis techniques which we commonly use in any of our research papers whenever we are going for primary data collection. So we thought of sharing these techniques with you. So if I start with the theoretical background, so the basic thing about any research is variables. So variables we divide into 2 categories. It can be independent variable and a dependent variable. I'll be sharing this PowerPoint slides with you also after the session. So in case you find any relevant information, you can just focus attention on listening rather than noting the points down. I'll be sharing this PPT with all the participants, okay, as well as the data sheets also after the session. So as I told you that variables, majorly we have 2 categories, independent variable and dependent variable. Independent variable whose value is not dependent on anybody, it just like that happens. And then dependent variable, which value changes, okay, it changes due to other variable change, not at its own. That's how it is. You can call a dependent variable as a lazy fellow also. So till the time independent variable will not change, dependent variable also will not bother to change. Like that also you can look on these 2 variables, independent and dependent. Okay. Another term I use it, an independent variable, it can be the leader who makes the way always, and dependent variable is the follower. So whatever independent variable will do, the dependent variable will also going to follow the same behavior. Okay. And how do we measure it? So in SPSS terminology, if I call them independent and dependent is a very layman term. SPSS requires little bit more explanation. It can be, so here we have 2 types of variables, categorical variable and continuous variable. Let us say if I talk about your age. So if you tell me that my age is 35 or my age is 45 or my age is 55 or my age is 10 or 8 or 9, like that, you're giving me a number. okay, or for that matter your salary or your weight. So if you just give me the number, that time I will call it as a continuous variable. Okay, and let us say if you give me the category about your age, my age is between, you don't want to tell me the exact number, my age is somewhere between 30 to 50, or my age is somewhere between 0 to 30, or my age is somewhere between 50 to 70. In that case I'm using categories. Okay, so it is as simple as that. So same variable is age varies. Okay, you can't stop it, so it is variable, fine. But how do we represent it? It matters. So it can be continuous variable, it can be categorical variable. When I'm representing the same variable by defining brackets or categories, I call it as categorical variable. And when I'm just taking a number, that time I call it as a continuous variable. Now within category, what all can happen? If the variable can be divided only into two categories, let us say a person, it can be either dead or alive, not in between. Nothing exists in between. Okay, so in that case I call it as binary. Okay, these days we have a lot of categories in marital status, but before, if you say the conventional method, either you are married or you are single. So only two marital status you can have, like that only. So same way, whenever any variable you can only categorize between two categories, that time I call it as a categorical variable of binary. When you have a nominal or ordinal, okay, these are two, so more than two categories whenever you have, either it will be nominal or it will be ordinal. What is nominal? When I am only taking names and I cannot provide any order to it. Let us say religion. Okay, you can't tell that which order I should follow. Hindu will come or Christian will come first, or Sikh will come first. It is just nominal. You can't tell me the preference order. Okay, there is no basis to order it. That time I call it as a nominal variable. But the moment I can provide an order, a preference, in that case I call it as ordinal variable. Let us say education, so UG, PG, above PG, okay, like that. Or age, as I told you, 0 to 30, 30 to 50, 50 to 70. In that case, I can provide a certain order on some basis. But in religion, can I do so? No, I cannot do so. That is why I call it as a nominal, which means only name. So naming, you cannot never order it, correct? And then comes ordinal, where you can provide a certain order to it. So when you have these categories, either two categories, you call it as binary. When you have more than two categories but you can't provide any order to it, it is nominal. And when you can provide order to it, it is ordinal. As simple as that. Okay, and continuous, again we divide into two categories. One is interval and one is ratio. What is ratio and what is interval? Interval means distance. Okay, let us say temperature. So when I say zero temperature, is there no temperature at all? No, still temperature is there. So this zero is exactly not zero. It is a kind of interval. Okay, so -1 also exists, 0 also exists, +1 also exists. So all the three numbers at every time temperature exist. How I am measuring it, that is difference. And then comes a ratio, so indicates a rank or distance from a natural zero. So when I say that my weight, this particular object has zero weight, in that case, yes, that zero, I mean it zero. But when I say I am at this particular place is having zero temperature, but that does not mean that there is no temperature at all. Yes, so that is arbitrary zero. That is how it happens. And this is something about frequency distribution. Once you have collected your variables, once you have collected your data, how you divide it. So one is normal distribution. We call it as a bell-shaped distribution. So bell-shaped distribution is simple, where you don't need to worry about that everywhere. It is like everybody has been included here. Okay, everybody is included. Here everybody is included. So in that case, what you will do, normally distributed. Let us say you have taken married people also, unmarried also, male also, female also, age wise also, all the age groups you have taken into your data, all the income groups also you have taken into your data. Let us say you are going for a study at a larger geographical dispersion. So in that case, all the kind of regions also you have included in your data set. So when everything is normally distributed, in that case data will be symmetrical, both the sides. I will not go much into mathematics of normal distribution. So simple meaning is that data is being normally distributed, which means everybody is getting equal opportunity there. Skewed distribution, which means that it has been focused on some point. Not everybody is getting equal opportunity. Okay, so skewed or kurtosis, both are telling you the data is not normal. So kurtosis means the point, two categories you have, positive or negative. So positive means a point is sharper and negative means a point is flatter. I'm talking about the bell-shaped curve. I'll show you the images also for that. And skewed distribution, which means that the bell-shaped curve, how it looks, okay, how far it is from the middle point, that is 0. Okay, so if it is not distributed equally, it will be a little bit skewed left or right. So that is how our distribution thing works. And these are the center of a distribution. So how do we measure it? It is measured using these three things: mode, median, and mean. So mean is nothing but the average of any data set, simple arithmetic average I'm talking about. And when I talk about median, so the number which is there in the middle when you're arranging it into the order, okay? Let us say ascending to descending or descending to ascending. In that case, you find out one median. And then you have mode. So the data set or a number which has occurred there most of the times, in that case, we call it as a mode. Why do we need all this knowledge? Because this is very basic thing about variables and their behavior, which we actually know before going for the major data analysis. Then after having a look about variables and skewness, normal distribution, then comes the hypothesis. Everybody knows here that what is hypothesis. Whenever you are going to conduct a research, in that case, what we do. Just a second, I'll just okay, fine. So hypothesis, basically I call it a hypothesis as an intelligent guess. Okay, it can happen, it cannot happen also. So using my research, I'm going to prove it, whether this situation occurs or not, whether it will happen or not. So like that hypothesis works. So there can be null hypothesis, there can be alternative hypothesis. In both the cases, what actually it means. Okay, null hypothesis means there is no difference, there is no impact, there is no association, which means that the situation does not exist. There is no relationship between two variables, or there is no difference between behavior of male and female, or there is no impact of particular variable on another variable. It means basically that that situation particularly does not exist. Alternative means it exists. Okay, if I say that yes, there is a relationship, yes, there is an impact, yes, there are the associations between these two variables, yes, that case I call it as alternative hypothesis. Hypothesis, again, as I told you, that it is a guess, and how this guess becomes true or false using your research. So using your research, you prove that hypothesis. So proving that hypothesis, for that we need certain tests, and for that we are discussing about all these chi-square correlation, regression, so that it will help us in proving our hypothesis. So significance level p-value. Now, how do I accept which is the null hypothesis, what is the alternative hypothesis? In that significance level, I have taken it as a 0.05. Okay, so significance level is 0.05. So if it is below 0.05, which means less than 0.05, we call it as that we have accepted the alternative hypothesis, which means that yes, there is the situation occurs. Okay, but the value of p-value, if it is more than 0.05, in that case I will tell that yes, there is no relationship, there is no association. That means that I am accepting null hypothesis. Okay, a very simple diagram is here. In that case, you see that if p-value is less than 0.05, you will be accepting your alternative hypothesis. If p-value is more than 0.05, you have to accept your null hypothesis. So any questions if you have, you can post in the chat box in between. Together I will take all the questions. So I hope so far it is clear. Okay. Next comes after hypothesis. Once we have framed the hypothesis, now the thing comes that how do we prove it? Okay, we can't prove it just like that because we have taken it, because I assume that yes, there is a difference in the behavior of male and female in terms of shopping of FMCG products, or looking at the advertisements, or going for impulsive shopping behavior does not mean that it happens that way. I have to prove it. How do I prove it? I collect primary or secondary data. In that case, I need to apply certain analytical test on that. And after that, I can prove it. So chi-square test for association basically tells me that these two things are associated or independent of each other. If they are independent of each other, which means that there is no relationship. I repeat it that chi-square test enables you to tell that whether they are related to each other or not, or associated. Association is the correct term because relationship we find out using the correlation test. So chi-square test basically only tells you whether they are somehow associated or not, positive or negative, that we will come to know during our correlation test. But are they are they associated at least? Okay, or they're independent of each other. So this chi-square test will tell you. If they are associated, yes, I can go further with correlation test or regression test or factor analysis, whatever I want to do it. So this is my basic level check. Okay, so you can test for ordinal variables and then you can do it for nominal variables also, dichotomous variables also. So in any case, you can do it. Okay, and then this test will not distinguish between dependent and independent variables. For chi-square test, they are same. Okay, who is dependent variable, who is independent variable, all that chi-square test will not tell you, and it will not discriminate also. For that, for chi-square test, they are just two variables and it will just find out the association between them, nothing more than that. And after chi-square test comes your null and alternative hypothesis. As I told you already that you call, so null is known as H0 and H1 is alternative hypothesis. So if H0 is that, how do we frame the hypothesis? Variable A and B are not independent or not associated. If I am framing the alternative hypothesis, in that case I tell variable A and B are associated. So when do I frame this hypothesis? When I'm going to prove it using the chi-square test. That time I need to use the term associated. So with the correct test, let us say I'm using chi-square test, I need to use the term association. When I'm using the correlation test, in that case, I need to use the term relationship. When I'm using regression test, in that case, I need to use the term impact. These are the correct terminologies. They are not interchangeable. Okay. And then comes assumptions of chi-square test. There should be two variables at least, okay, and there should be two or more groups in each variable. Let us say I can only find out association between male and age, marital status and age, or I can find out the association between education and gender. Okay, so in that case, it can only happen with the categorical variables, if I say so. Done. This is how your bell-shaped curve looks. Okay, if it is normally distributed or if it is skewed. So normally you will see a nice bell-shaped curve comes. Skewed means no, this bell-shaped curve is little bit pressed to my right side, your left side, I think so. Okay, and that's how it happens. So this bell-shaped curve is be little bit pressed towards another side. And this is how skewness looks if you say kurtosis values. So when it is sharper, when it is flatter, when it is left side is skewed, when it is positively skewed, negatively skewed, or like that. So we can also derive the values using the test. That also I will show you how do we find out the values of skewness in case your data is not normal. So this is how it looks if your data is not normal. And also to find out the normality or to check the data, whether your data is normal or not. If you are so particular about that your data has to be normal from all the angles, you can go for this test also, that is known as Shapiro-Wilk test. Shapiro-Wilk test is recommended for a small sample sizes, and it's not confident visually. So if you are not able to draw the diagrams and you're not able to correctly identify that your data is normal or not, in that case you can go for this test. And generally they say that when the sample is larger, you get your data normally distributed. So where the problem occurs when you have a very smaller sample size. So you see here the significance value, if you see significance value is more than 0.05, which means data is not. So in Shapiro-Wilk test, if you see, it is opposite. So if the value is more than 0.05, which means the test is not significant, which means that data is normal. Okay, so that is how it happens. So if significance is less than 0.05, then null hypothesis will be rejected and data is not normal. But here it is opposite. You see that significance value is more than 0.05, which means data is normal. This is the only test where you are accepting the alternative hypothesis even if your value is more than 0.05. In all other cases, p-value is less than 0.05 to be accepted. Now, theory about factor analysis, how it happens. I'll take you to the data sheets also once we just finish the theory part. So factor analysis, it is basically a test which actually helps you to reduce the number. Okay, let us say you want to define a person and you are giving their personality traits. So you say the person is attractive, the person is smart, person is talkative, person is extrovert, person is a good public speaker, person wears nice clothes, he looks or she looks fair, tall, all that. So when you talk to 15-20 people, they tell you different characteristics of the same person, but the person remains same. So every time if I want to define that person, I might not use all 15-20 terms. In that case, what you do, you want to reduce it. So whatever is slightly related to each other, I will just combine them. So I do the grouping. That is what happens in the factor analysis. We call it as dimension reduction. So in that case, what happens that the portability of data increases. I call it as portability of data. Okay, it becomes very easy for you to take that data further. If I say that you have 20 people for with them you have to go for a journey, and every time you call those 20 people separately, it becomes a little difficult for you to coordinate with them. So in that case, what you do, you you make few groups among those people, only 20 groups. Let us say you make 4 groups, so 5 people, 6 people, 8 people, like that you are making groups. Okay, and then every time you just coordinate with a group leader. So you just need to now coordinate with the 3 people rather than coordinating with 20 people. Rather than calling 20 people at a time, now you need to only call 3 people, and then the entire group comes along with. So this is the beauty, okay, of factor analysis. It tells you, so let us say you have 100 people, 50 people, together you just dimension reduction you do, and that group will be divided into subgroups. That's how the data will be reduced, okay. And how we reduce it? Now let us say you are going for, as the same example, if I tell that you're going with 20 people, now you need to divide them into groups. How will you divide it? You can't just randomly divide them, because if you randomly divide, those people will fight again. So then again it creates a chaos. So what you do? You divide them, those who you see that yes, their characteristic matches, or these people like each other, or they have some common traits. Okay, so that thing you analyze, and then you divide them into groups. Same thing factor analysis also does. So in the background, factor analysis will do correlation analysis. So whosoever is having high collinearity with each other, they will be formed into one group. Like that, factor analysis will do the grouping of those variables. So if 20 variables are there, 7 are there, 7 in another group, and 6 in another group. So now the entire grouping is being done. 3 groups, or let us say 4 groups, depending on the relationship what they are showing with each other. Sometimes you will see that after running the entire factor analysis, the one group has only 2 variables. What it means? Only 2 people are there who like each other. Other than that, their characteristics are not matching with anybody else, which is fine. Like that, factor analysis works. Okay. So I've told you the basis also how the factor analysis will group this or will reduce the dimension based on that correlation analysis which happens in the background. Okay. After factor analysis, there are 2 basic terminologies which will help us in the further analysis also. One is EFA and another one is CFA. So EFA is exploratory factor analysis, confirmatory is CFA. It is very simple differences there. EFA means when I do not know these many variables will come out with how many factors. So I'm exploring it. Okay, that case I run exploratory factor analysis. But when I already know that these 25 variables are happening into these 5 groups, that time I call it as CFA. Now you will ask me that how do I know that these people are divided or these variables are divided into these many groups? How it happens? CFA comes from a very long process of theoretical building or review of literature. CFA will not come in one day. Best example or one of the example for CFA is service quality model or your TAM model. They have been established long back and many people, thousands or lakhs of researchers have already used them. Whenever they run factor analysis, if they have collected the data correctly, these are the 5 groups which will be always formed. There are dimensions, okay, responsibility, tangibility, all these things will come every time. So why it happens? So with the experience, we say that service quality questionnaire has these many variables, which will be divided into 5 groups or 5 dimensions or 5 factors. So that time I call CFA. So when I'm using service quality questionnaire, I do not need to run EFA because I already know what is going to happen. Correct? On that basis, already so much work has been done. So it is like that those 25 people go for a trip every time they go into same group. Okay, and after 10 years also, if a teacher comes and then they again need to divide those people into a group, yes, they know that how it happens. So the same thing is with CFA. Already it has been tested so many times. These dimensions are being fixed. So CFA is nothing but your review of literature. Okay, which suggests you that these variables have these many factors. But EFA, you collect the data and then you only explore the factors. That how many factors this particular number of variables will have. That is why I call it as EFA. Okay. And extraction, how do I extract those factors? I use the analysis known as principal component analysis. So whichever are the main components, it will be extracting from it. Okay, there are so many other methods also, let us say principal axis factoring, alpha factoring, but we only use principal component analysis. Okay, principal component analysis is the simplest one, which helps us to reduce the number of variables. But PAF, which is principal axis factoring, it is used based on theoretical consideration, which we generally do not do. In most of the studies, we do PCA, that is principal component analysis. That's how we extract factors from those number of variables given to us. These are few basic concepts about factor analysis, factor loadings. So what is factor loading? That it is nothing but a correlation value. Okay, how you are related, and if you are having high factor loading, which means that high correlation you are showing and high importance you are showing. So the variables which are having factor loading like more than 0.8, they are strong. Your entire theory building will be dependent on them, and for any case, you should not discard them from your questionnaire if you go for pilot study and all. So factor loading basically tells you the dominance level of that particular variable in your study. If it is having very low factor loading, 2.2, 0.3, 0.1, which means that no, you should not take that variable further. That's how it is suggested. Just like a kind of baggage for you. If you take it further also, it will create problem for you. So rather than leaving it in this stage only, it is suggested. Then these are few more parameters by how you will be able to fetch those information pieces. Eigenvalues. Eigenvalues nothing but when you have the eigenvalue more than one, that will be known as a factor. Okay, and scree plot. A scree plot is just a graphical representation of a factor analysis. Okay, how many factors are have become a particular component and who is related to whom, like that. A scree plot will tell you. Eigenvalue basically tells you that how much importance that particular variable has. So if the importance is 100%, then it becomes a factor. If it is less than, no. Okay. Scale reliability. Scale reliability is again to establish that how reliable your variable is. So in this case, suggested value is always more than 0.70. What it means reliability? Reliability means if the value is less more than 0.70, which means that this particular variable, I can trust at least 70% for the information, which is sufficient to trust. Okay, so this is the basic level. So if a variable is trustable or reliable, at least 70%, we can keep it for our study. We don't need to discard it, but always it is suggested that it should be close to 0.8 or 0.85. Okay, and then there are various things also to check the reliability, but one is very common measure is Cronbach alpha. I'll show you how do we calculate that Cronbach alpha also. And if I talk about CFA, so again the factor loading, as I told you that factor loading always should be, so minimum it should be 0.5 at least, even if I talk about reliability. So in the worst case, I can't go below 0.5, whether it is factor loading or it is reliability, Cronbach alpha, because that's how less than that I cannot compromise on my study. So at least 0.5 has to be there. And about sample size, yes, sample size less than 100, not very suitable. So if you are going to have factor analysis in your study, at least your sample size should be between 200 to 300. That is adequate number. And if you have more than 500, it is excellent sample size. And then comes correlation and regression. So once you are done with the factor analysis, so that groups or individual variables you can take for correlation and regression, you can check about their relationship and how much they impact each other. So let us say that chi-square test is a one basic level check whether two people are associated with each other or not. So if chi-square says yes, they are associated, then I will say, I will go and check further using correlation analysis. Are they positively related to each other or they are negatively related to each other? That much I know, they are associated. Okay. So now if correlation tells me they are positively related or they are negatively related, in that case, I need to know that how much one impacts another one. So now I need to see who is having impact on who is independent, who is dependent. So by the stage I reach to regression analysis, by this stage I should be able to identify my dependent and independent variables. Then only I can run the regression. Regression test is to find out the level of impact. Okay, let us say two people are there. So those two people, do they know each other? Is there any kind of association between them? I conduct chi-square test. Then chi-square test tell me yes, they're associated. Then I need to say, are they friends or they are enemies? Okay, are they impacting each other positively or negatively? So if correlation test tells me that yes, they are impacting positively each other, in that case I need to see that who is having positive influence on whom. Okay, so regression will tell me the value. Let us say regression value comes to me minus 0.4, or sorry, correlation value comes to me 0.4, which means that positively they are related. So this person is related to another person, 40% is there. Another 60% relationship comes from the another person. And then comes the regression, how much impact it has. So let us say regression analysis tells you plus 0.03. That means that 30% probability, 30% time, this fellow listens to the another one. That is how the impact thing works. Okay, so correlation, again, if you do go mathematically, there are two things. One is Pearson and then Karl-Spearman rank correlation. So simple thing, when do I take Pearson, when do I take Karl-Spearman correlation coefficient? When my data is normal, I'll go for Pearson's correlation. When my data is not normal, in that case, I need to provide a ranking order to my data and make it behave normal. Okay, that's how it has to happen. And then I run Karl-Spearman correlation test on that. And then I'll find out the relationship between both. So Pearson's product moment correlation, it will again, the correlation value will be somewhere from -1 to +1. And if it is 0, which means that there is no relationship between both, which means 0, that means both are independent of each other. There is no, they don't know each other basically. And these are few assumptions from SPSS point of view. If you want to see, data should be normally distributed, there should not be very significant outliers, and there should be a relationship between these two variables. And Spearman, as I told you, that you provide a ranking order to your data and then you can run correlation on that. That's how you call it as Spearman rank order correlation. And these are few assumptions that two variables should be there in paired observations, and a monotonic relationship between two variables should exist. It can be, you can run that between two continuous variables or two ordinal variables, or one continuous and one ordinal variables. I've already explained you what is continuous and what is ordinal variable. Okay. And after a correlation check is done, suppose you find a positive or negative correlation, and then you want to quantify the amount of relationship, how much impact it has having. In that case, you go for regression analysis. Here we are only talking about simple linear regression. There are so many categories within regression also, multiple regression, logistic regression, so many are there. But here we are only talking about simple linear regression. So it will predict the how much dependent variable is influenced by independent variable. Okay. So this is just example, one independent variable. It can be height, exam, performance. So if I am taking from management perspective, height is independent variable. Okay, and on your height, weight can be dependent variable. Correct. So it's not like that the one variable which is dependent is always dependent only. Sometimes it is independent, sometimes it is dependent. So if I say my age, so most of the time age will be an independent variable. Okay. And if you see that height, weight, so height also it is independent, but then again you can see biological things, and then geographical factors, all that will also influence your height. Okay. So that's how your these variables will differ, and their presence in terms of independent or dependent. And so what kind of problems you can solve using simple linear regression? You can predict new value for dependent variable. You can use it for basically forecasting purpose. Okay, you will have a simple linear equation, and using that equation you can find out the values for different variables. You can determine how much of the variation is in the independent variable or dependent variable, which will be explained by the independent variable. Okay. And which are the assumptions for testing? You need to have two variables basically, and there should not be very significant outliers. Who are outliers? Outliers are the people or variables which are not having any kind of discipline in your data. Okay, so every time you talk about X and they talk about Z. So we don't need them in our data. So if you have any kind of significant outliers, before conducting any test only, you have to remove them. Okay, and independence of errors or residual errors, so all that should be lesser. And so basically a simple linear regression you can run between two variables, more or less you know which one is dependent and which one is independent. So that is the basic understanding you need to have about simple linear regression. Okay, and how much is the impact that you can quantify. This is one brief table how it comes out. So if you see that the same thing I'll show in data sheet also. So your cholesterol basically is dependent on time spent in front of TV. Okay. So you see that time in minutes is spent watching TV. So if you see this equation minus 0.944, that is the constant, plus 0.037 multiplied by time spent on TV in minutes. So 0.037 is the amount of impact. Okay. If I convert that into percentage, you have to multiply it by 100, which means that 37%. Fine. And you see that it is having significant impact because it is 0.0. So which means that 37% times cholesterol will be impacted due to how much time you are spending in front of TV. Okay, so constant is just a garbage bin. Okay, it does not, constant guarantees that your residuals have a meaning of 0. All the errors part, everything will be taken into the constant part. Okay, and so this is how we interpret it. A linear regression established that daily time spent watching TV could statistically significantly predict cholesterol. So in that case, significance level is less than 0.005, and the time spent watching TV accounted for 14.3% of the explained variability in cholesterol concentration. So the regression equation is like this. Now we'll go for the practical part of all these concepts. So I'll share the data sheet now. I'll just have a look on the doubts which you people have shared. Okay, I'll just spend 5 minutes here, whatever doubts we have been posted here. Okay, so PPT I'll be sharing you. So the first question is how we can determine the value of p-value, where we can use the p-value. P-value is nothing but the significance level. So the bracket or the borderline, if I say it as 0.05, if it is below 0.05, in that case it is significant. If it is more than 0.05, the test is not significant, and it is applicable for most of the times. Okay, except your Wilk-Shapiro test, it is applicable every time. And difference when chi-square test, yes, we can use it. Okay, no problem with that. Difference between chi-square test and correlation and regression regarding association, as I told you, very simple thing. Chi-square test is just to check the association. Are they associated? Correlation, are they related? If related, positively or negatively. This much information you will be getting from correlation test. If they are related, then comes regression. what is the impact? Okay, positively or negatively, how much one is impacting another one, who is dependent, who is independent. Okay, and CFA, going for CFA is not mandatory as soon as you are only doing multiple equations. But if you want to have everything together, then if you want to go for a structural equation modeling, basically you should go for CFA. Other than that, it's not required. Okay, and correlation and this I have already told you. Normal data means equally distributed, where every sample is getting equal opportunity. Okay. Then residual is nothing but the error, okay, which we could not measure. That thing is known as residue. You can collect data from Likert scale for this purpose. How to determine sample size? Sample size can be determined using different formulas, and there are different approaches to calculate sample size. Okay, each test also has its own requirement, how much sample there should be. And how much should be the sample size for factor analysis? As I told you, suggested one is more than 500, but up to 300 or 400 is also okay, no problem. So, Shapiro-Wilk test basically we apply when the sample size is less than 30 or close to 30. That time we have to be very much particular about the normality. As your sample size increases, normality actually most of the time it will be taken care. You don't need to worry much about it as your sample size is bigger. Okay, so now I'll share the screen data sheet. So the first data sheet I'll be sharing is about the introduction of the sheet. I'll just quickly tell you what how this sheet looks and what all we need to take care there when we are making a SPSS data sheet. So rather than you prepare your data into Excel sheet and then you fetch it in the SPSS, better it is that you directly, I hope it is visible now. Yeah. So this is how one SPSS data sheet looks like. You can enter any type of variable, whatever you like here. So it is better always that you start entering your data into SPSS sheet only. So there are two views, variable view and data view. So if you go to data view, it just looks like an Excel sheet only. Okay, there is no difference. And if I go to variable view, so this is how I need to enter my data. So variable name you enter here. What type of variable it is? If you are only entering your age into numerical number, numeric. If you are only giving the categories and then you are telling category 1, 2, 3, 4, 5, that time also you can use numeric. And let us say gender, if you are only using string, you are only using male and female, you're not coding it. That case you use it as a string variable. But most of the time when we are doing coding, everything comes here as numeric only. And if you see what are the things available here, you have numeric, comma, dot, scientific notation, date, dollar, currency, string. So most of the time it is either numeric or string. In that also we have numeric. Okay. Width is nothing but how many numbers it can occupy. So it can be 4, it can be 1, 2, whatever number maximum you want to take there. Decimal points, if you want to allow decimal points, let us say if you want to say my weight is uh, 60.0, or my marital status is two categories I've given them, married and single, and then married I call 1 and single I call as 2, and then I tell them 1.0, 2.0, does not make any sense. So in that case, decimal point will not look good. So I don't put decimal, I put it as 0. But if you need any decimal points, in that case, you can always put it as 2 or 1, whatever it is required. Otherwise, make it as 0. It will not look good. Okay. Then here you can just give a short name, but in label you can put more details. You can even use a space bar, any other thing. Here you can't give any space. Okay. So if you want to conveniently define your variable, what it is, what information it captures, so in that case you can write details in label section. Values, if you see that here, if I have provided, so I call unmarried and married. So unmarried is coded as 0, married is coded as 1. Okay, so that is how, if you want to add any other category, you put their value as 2 and you call it as don't know. Okay, and you just add it. Then if you want to delete it, remove. And so that is how you can define your categories of a variable, whatever you have taken, how you have coded into your questionnaire. Missing values, if you want to also capture missing values, you can capture it as, okay. So normally we call it as any missing values you can keep here, 999. Okay, otherwise not required also. In that case, no problem. Column, it comes automatically, no need to do anything. Alignment, if you want to do formatting, left, right, center, whatever you want, automatically it comes as right. Okay. And then measure, this is important thing. If you see a scale, it should be correct actually, otherwise it will create problem for you later. So 3 categories you have here: scale, ordinal, nominal. As I told you, ordinal, when you can provide the order of preference, call it as ordinal. Nominal, when you have categories but you can't provide any order to it, call it as a nominal. And scale, when you are just capturing numbers, let us say weight or height or age, in that case you call it as scale. So this you have to correctly, but if you are just importing a data sheet from Excel, it will not come correctly. So you have to correct it manually, and then this row or input, it also comes automatically. So this is how it looks, a basic data sheet of SPSS. And then there are few controls if you want to see that, let us say you want to go to case, or you want to go to variable, or you want to run descriptive analysis. There are various tabs available that also I will show you. You want to split the file or any way, you want to select cases. A lot of controls are available there. So that we can do. And if you want to generate charts or graphs, you will see here directly it has been given to you, chart builder. So just you go to chart builder, and before okay, so whichever chart you want to draw, you can draw using it. Okay, and then if you want to analyze anything, let us say you want to analyze about the frequencies. So in that case, I take this income category here, and I want to calculate primary vehicles. So in that case, what all you need in your descriptive analysis, you just click on the statistics, and whatever data you need. I need mean, I don't want more, but I need mean only. And then I also want skewness, kurtosis. I also want to see standard deviation. I also want to see range. Okay. And then if you want to see any chart, yes, I want to see bar chart. If you want to see histogram, if you also want to see your normal curve, fine. And then format, don't need to do anything. Style bootstrap, also nothing. So if you just press OK, so it will come. It takes little time to generate the result, but this is how it comes. Okay. So your frequency tables have come. So you will see that economy, standard, luxury, what is the frequency, total number, and then percentage. Okay, everything just comes with a click. And everything comes neat and clean, and you just copy it by using right click and paste wherever you want, and then you can do the formatting as per your choice. If you want to see the bell-shaped curve, yes, it has come. See how nicely it has come. So both the variables are showing. Now you will see that whenever the data size, sample size is more, here sample size is 6400. So more or less you will get normal data only. Okay. So these are the details which we wanted. Also, we have looked for mean value. Okay, you will see that mean value has been given for both the variables. We wanted skewness and kurtosis. So this is how it is. There is no missing value. Okay. Missing value concept also tells you that let us say manually you have forgotten to enter any value. So here you will see any missing value 1 or 2. So later you go to there and you manually check it, and you can just fix it, or you can just delete that entire response of that respondent. So this is how SPSS sheet looks, and we do the data analysis. So then I'll take you to the factor analysis and regression techniques also. You can try out different controls. So next one is simple linear. Sorry, I wanted to show you first the factor analysis. So this is the sheet for factor analysis. So here if you see so many characteristics have been taken for a celebrity. Celebrity can be attractive, classy, beautiful, elegant, exciting, dependable, honest, reliable, trustworthy, sincere, expert, experienced, knowledgeable, qualified. So how do we run the factor analysis? We just go to analyze. Here only you will see all the tabs, whatever you want to do. Okay, descriptive analysis, or ANOVA if you want to do, or you want to have your chi-square test, or you want to do the correlation analysis, regression, and then comes dimension reduction. So here you see factored analysis. So if I click there, and whatever variables are there, I just need to take everything because I want to run factored analysis. So these are the variables I have taken. 14 variables are there totally. What all details I want? I want KMO Bartlett's, which will tell me that my data is sufficient to conduct factor analysis or not. And then I want initial solution. I want extraction. So extraction, we always use principal component method. If you also want to see a scree plot, you can check here. Okay, and it comes automatically based on eigenvalues. Okay, and then rotation. So we always use Verimax. This is the best one. Rotated solution, and then scores, we don't do anything. Just let it be. Options. If you want to see sorted by size, like factor loading, as I told you that time you can do it. Okay, if you don't want to do it, no problem with that. If you don't want to see values which are less than 0.5, you just want to get it, so you can just put this value, otherwise all the values will be visible to you. Okay, and continue, and then you run the factor analysis. So the result will come. So here you have seen it. So starting from KMO values. So when significance value comes as 0.0, which means that the test is significant and we can accept the values, and the value is 0.780, which means that the sample which I have taken for factor analysis is sufficient to conduct a factor analysis. So this value should be more than at least 0.5, which is the worst case I'm talking about. Ideally, it should be close to 0.7, 0.8 like that. So that is how your KMO value should be. So KMO value, which basically tells me that how sufficient my sample is to conduct or proceed with factor analysis. So this is one kind of go ahead to me. Yes, you can go ahead with factor analysis. And then communalities. So it tells you that what kind of extraction values they are showing you. You can just ignore this table. You need to focus on here. So this is total variance explained. Variance is nothing but how much information you are giving me. Simple. So if you see that the total is 70.59, which means that these 14 variables are explaining me 70% of the information. Remaining 30% information is lost or not told to me by these variables. Another simple words, if I tell you that I used 14 variables to define a celebrity. In that case, it tells me that 70% of the characteristics of a celebrity is being defined by these 14 variables or these respondents. 30% information is not available to me, which is digestible. But if I say that only 30% I'm explaining with my research and 70% is lost or not known, this is not taken. So that is how this total variance explained thing works. So my first factor explains 41% information. Second factor tells me 17% information, and third factor tells me 12% information. Remaining 30% information is not being explained, which is okay. Scree plot, you see here. So scree plot, so first factor, second factor, and third. And so you see eigenvalues are given and component numbers. Totally 14 factors we have. And whenever eigenvalue is up to 1, it will become a factor more than 1. Okay. And 1 less than 1, they all are just variables. So they have to, so these are the leaders basically in data set 1, 2, 3. They are the leaders. Others are followers. They will follow them. So now I need to interact with these 3 people. Basically out of these 14, I need to only interact with these 3. These are just followers of these people. Okay. And then comes my component matrix. I don't need to focus much about it because I need to see the rotated component matrix because that gives me the better view. So you see here why these few values are not visible, because I just enabled the option that wherever the values are less than 0.5, I will not be able to see those. Okay, so this is how it is. So rotated component matrix and factor 1, factor 2, factor 3. So these 1, 2, 3, 4, 5, 6 items belong to factor 1. These 3 belongs to factor 2, and these 5 belong to factor 3. So this is how grouping has happened. Okay, so now we just can give a common name to these 6, these 3, and these 5. So we have come out with 3 factors rather than carrying all 14 variables every time. We call only these 3 factors. This is how the dimension has been reduced. So this is your factor analysis, and then I'll show you the correlation and regression also. Yes. So for correlation and regression, the same thing we are doing here. We just need to see first of all whether they are related to each other or not. If they are related, then how they are related. Okay. So this is the simple sheet for simple linear regression. So first of all, I want to find out the cholesterol is a dependent variable for me, and time spent in front of TV is independent. Okay, I can spend any amount of time in front of TV, and that will define the level of cholesterol in my body. So if I go for correlation, sorry, analyze, I go, and then correlate. Bivariate only I need to press, and then you will be having it as so I take both the variables, and because my data is normal, so I use Pearson, and flag significant correlation, so it will just highlight if it is correlated. In options, nothing we need to do. Style bootstrap also nothing. So either we choose the correlation coefficient and two tail, one tail. So we go for two tail. Test of significance. Okay, and just press OK. So this is how the correlation value has come. So yes, they are positively correlated, which means positively correlated means that if my time in front of TV increases, cholesterol also increases. Okay, that is how they are related. How much influence it has now, that we have to see using the uh, value. Okay, so now again I go to analyze, and now I need to find out the regression. So I go for linear regression, and there here I have to define now. Henceforth I can't escape from defining my dependent. So my dependent variable is cholesterol, and independent is time in minutes spent in front of TV. Statistics, what all you want to see. Confidence interval, model fit I want, descriptives I want, and nothing much. Okay, and continue. Plot if you want any. Histogram if you want to see. Normal probability plot. Okay, and then options. Nothing you need to do here. So this much is fine. And then you just press OK. And the result will be generated. So regression result will come. So this is how the result has come now. So first table, okay. So descriptives has come. Okay. So number of sample sizes there, 100. Mean value, standard deviation. Then correlation, again it is showing you the same correlation which you have seen earlier also. Then variables entered. So these are the two variables entered. R square, which means that this much information it explains. Okay, 15% is the reason why time spent in front of TV influences your cholesterol. Remaining 85% is happening due to another things. Now you will tell me that 15% is very less. Why we are accepting it? Simple thing is that when my cholesterol in my body increases, it's not only because of TV. There are other things also. So here I have only taken one factor, which is time in minutes spent watching TV. So that will not identify the level of cholesterol in my body. It only has a small percentage of information to do. So 15% looks okay. I can accept it because it is in the context of my study. I can accept it. Okay, and then ANOVA, whether there is any kind of associate difference in terms of groups. Yes, it is. Okay, and model summary, this is important for me, which I have already explained to you. Coefficients, this is the table for unstandardized and then standardized. So residual statistics, if you see, maximum, minimum, and this we don't use much actually. If you want to see your histogram, this is how it is looking normal, and this is how it looks. So if you see, these are your respondents, all that small circles which you see. So let us say all the circles are coming on this line only, which means your data is almost normal. If you see these few people are a little bit moving away, but that is okay. But if you see somewhere here or there very far, those people are known as outliers. So in this data we don't have any significant outliers, so I call it as a normal data. Okay. So that is how we have found out the our model summary is there. Yeah. So this model summary actually tells you how you will define your equation. So this is how you run your factor analysis, regression, correlation, and all. Okay. So our okay, I think most of you were not able to see the output window. I'll just show you again. Give me a second. So output window for factor analysis, I should show, I think so. Okay, so first I'll show you this thing. I think now it is visible. So this is how the output window of correlation and regression looks. Descriptive analysis I have looked for. So first of all, it was correlation thing. So when we calculated the correlation, this is how the result has come. So they both are positively related to each other. 0.389 is the value of correlation. Okay. And then when we run the regression analysis, so this is how the regression thing comes. So in regression, we have looked for descriptive statistics. So this is how your descriptive sample size, standard deviation, mean value. So most important value in your regression is your model summary. This I was talking to, R square value is 1.51. So this is what we have to explain. Okay, so 15% information is available due to your equation. Okay, so 15% is the reason why your cholesterol increases due to time spent. The 15% information is only explained due to this thing. So 85% your cholesterol increases or decreases due to other factors. So for that, time in minutes is not a responsible thing. Okay, and then you see this equation, coefficients. It helps you to frame your regression equation where constant value is given and correlation coefficient value is also given. Okay, so this is how we do it. Okay, so now I'll take questions. So few of you have posted questions, and then we'll take a break of 15 minutes for our next session. So in that case, factor analysis is important. As I told you that it reduces or helps you to increase the portability of your data, and it helps you to do the data packaging. Basically 14 people were there, we reduced into 3 only. So now I need to only interact with those 3 factors, not with the entire 14 set of variables. Whatever correlation, regression I need to do, only between those 3 factors. That is how it will happen. Okay, and then I'll take a few more questions. So regression analysis, as I told you, it is used for having your impact. Okay, what is the impact of one variable on another? So when you are running regression, you need to actually define your dependent and independent variable very much clearly, and then it will tell you how much impact independent is having on dependent. Okay, or dependent is having on independent. That because as I told you that sometimes it happens both the ways also. So that's how you have to define it. And Likert scale is ordinal scale. Okay, R square value tells you that how much information you are explaining using this model. And PCA is performed. Do we need to check for reliability of the statements under each factor extracted? PCA is also a kind of parameter which you can consider for a reliability, because if factor loading is again less than 0.5, those variables are not reliable. So somehow if you have escaped that stage, if you have not taken reliability test in the beginning, in factor analysis those variables will trouble you. So it has to happen one way. So it is better that if you conduct that Cronbach alpha test and you remove them then and there only during your pilot study, rather than keeping and bringing them to your factor analysis and losing them here. Okay. In management research, regression or factor analysis or ANOVA, they all have different objectives. ANOVA, when you want to compare between groups, let us say male or female, whether they show different behavior or same behavior, I use ANOVA. Okay. Age-wise, different age categories, whether they show same behavior for online shopping or different behavior for online shopping, I go for ANOVA. But if I want to have the impact of gender on online shopping, I will go for regression test. Okay, and I want to reduce the number of dimensions. In that case, I'll go for factor analysis. Okay, so this is how it is. So we can take a break of 15 minutes and then we'll start with the structural equation modeling. So we'll not end the meeting. You can just switch off your video and 15 minutes break will take.
We'll resume back within 15 minutes. Dear participants, kindly note, I'll be sharing 2 links with you in the chat box. And this link, you will have to install R and R Studio using these links. And this is for the session that will take place tomorrow. I repeat, I shall be sharing 2 links with each one of you. Okay, and you shall go ahead and download R and R Studio on your computer systems for the session that will be conducted tomorrow. Thank you so much. And now I shall be sharing the link with each one of you on the chat box. So as you can see in the chat box, I have shared both the links. Please go ahead and download R Studio and R from these 2 links and come prepared for the session tomorrow. Now we shall have a 15-minute break and then we shall resume back with you at about 4:40. Okay, and some of you have asked for the link.
Rohit, actually, some of the participants are requesting the link in email.
Yes.
You would have received an email for registration details. In that email also, those links have been mentioned. Where we have sent you the meeting details. Both the
Okay.
links are available in that email itself.
All right. Thanks, ma'am. Requesting the participants to kindly look out for your email for the link for the link of R, which you have to install on your computer system for tomorrow's session. And also, some participants have asked for the PPT that shall be sent to you at the end of the 2-day FDP. That shall be sent to you via email. All right. And the attendance link for today will be shared 15 minutes prior to the closure of the session. I repeat, the attendance link for today will be shared with you 15 minutes prior to the closure of the session. Thank you so much. And we sincerely hope you are having a great learning time out here. Thank you again.
So we will begin with the next session now. I'll just share the screen. So in the previous session, we have briefly discussed about the usage of SPSS and I'm audible, correct? Okay. So in the last session, we have discussed about the SPSS and commonly used tests such as descriptive analysis, correlation, and regression, factor analysis. In the software, structural equation modeling, actually it enables you to run multiple equations at a time. So let us say you have different multiple regression equations, multiple dependent variables, multiple independent variables, and you kind of having a complicated structure in your research. Okay. So in that case, structural equation modeling helps you. So what you do in that case, you have to have you can't run a regression equation. Let us say you have three dependent variables and then independent variables are 7 to 8 independent variables you have in your research. So every time one variable you take and then you define your research, which path goes where, who is impacting whom, how the flow chart is working. So in that case it does not happen that way. What we need to do here in that case, we need to have a mechanism where everything comes together and then we can see that what is actually happening in this research. So in that case, structural equation modeling, this AMOS helps us. AMOS is nothing but analysis of moment structures. This is the full form basically. And in this session, we'll be talking about structural equation modeling, confirmatory factor analysis, exploratory factor analysis, interface, how do we improve appearance, and then how do we identify the model, and what is a structural model and how it actually looks. It looks complicated from outside, but it is very easy. So what happens here in that structural equation modeling, as I told you that it will have multiple variables, multiple relationships, different paths, and different category of variables it will be having. Some we can measure, some we cannot measure, observed, unobserved, errors, okay? Everything will come here. And then confirmatory factor analysis, I've already told you a little bit about the CFA. So CFA is basically nothing but when you already know these variables have this kind of factor structure. In that case, I know I have confirmed factors with me. And how it comes, it does not come with data analysis, it comes from review of literature. So CFA is nothing but review of literature. EFA is nothing but analyzing those variables, reducing the dimensions, and it is basically data analysis. CFA is not data analysis, CFA is just review of literature. This is the basic difference between these two, EFA and CFA. Okay. So you see kind of a structure. Okay, when we are having multiple regressions. So you see here, this is simple one. Okay, everything, these are your independent variables, which influences your dependent variable. So y variable will change when x changes or x2 changes or x3 changes or x4 changes or x5 changes. Here, if you see a complicated structure, okay, x3 is having influence from x2, x3, x4, like this it is going on. So many paths you are having here, okay. So this is how, in this scenario, we need a structural equation modeling. This can be sorted with using SPSS or regression equation model also. But for this, we need structural equation modeling, this kind of scenario whenever you have. So how you make equations. So you have here basically 4 equations. One equation will not solve your purpose. So you need to have multiple equations, and then multiple times you have to frame hypothesis, and for each path you have to conduct separate tests. So to avoid all that hassle, we go with the differential equation modeling. Okay, so differential equation modeling basically is a statistical technique for testing and estimating causal relations using a combination of statistical data and qualitative causal assumptions. When I say statistical data, for each variable I have collected data, and when I say qualitative causal assumptions, in that case I'm talking about CFA, which has come from a review of literature. Okay, so it is a combination. We need a thorough, strong review of literature for CFA purpose, and then we also need to collect data for verification purpose. So ACM is basically a combination of factor analysis and regression. Okay, and it directly connects your path diagrams, equations, and it will fit statistics. Okay, which path is going where, what is the value of correlation, regression, factor analysis, everything will come together. And how do we make model? So conceptual model, first of all, we have to make which variable is related to which variable. That's how you make a theoretical framework first. And once that theoretical framework is ready, then we need to draw it on our interface, and then we just fetch the values, whatever we have collected using our data analysis. That is how it is done. Few jargons which we use here. Measured variable. So in practical aspect, what happens that there are few things which I can go and measure. Let us say if I want to ask you your gender, you will be able to tell me. If I ask you your age, if I ask your income, if I ask you your weight, or if I ask you how much spending you have done on this particular website, you can tell me easily. But if I ask you that how was your shopping experience, or how was your experience in this particular hospital, or how was your attitude towards new e-commerce policies, or how was your attitude towards government policies, or how is your attitude towards influence of COVID on education? So in that case, you can't really tell me a very significant, clear-cut, close-ended answer. Yes. And how will you tell me unless you measure it? Can you tell me in a number? If I tell you that how much importance you give to offline shopping or online shopping, you can't tell me a number in that case, correct? So in that case, I have to have a mechanism to measure it. So I cannot directly measure it. I need to have some kind of support to measure this. So let us say if I want to measure service quality, I want to measure shopper's experience. So in that case, I need to have a mechanism. So I need certain questions to ask you. Once you answer those questions, then I can measure how was your experience. Correct? That is how it happens. So when I'm using this kind of technique, so service quality, it is unobservable. But if I ask you that, are you happy with today's shopping? You can say me yes or no, or how happy you are. So if I give you a scale of 1 to 5, in that case, you can tell me 1 means I'm not happy at all. If I tell you, if your answer is 5, which means I'm extremely happy with my experience. So in that case, if I give you few measurable or observable variables, in that case, using those observable variables, I can also measure unobservable variables. I hope it is clear. Okay. Service quality directly I cannot measure, directly I cannot observe. But if I give you 15-20 questions, with the help of those questions, I can measure it. Correct. So this is something like that only, measured variable, which I can measure, I can observe, or it indicates something. Okay. Predictors of that path. And so how do I represent? I put a square or rectangle, whatever I can measure. And then comes latent variable, what I cannot measure directly. As I told you, service quality. Service quality is a latent variable, okay, which I can't measure directly. So in that case, and then comes construct driving measured variable in the measurement model. And how do we denote it into the diagram? Circle. So whatever I can measure, I take as a square or rectangle. Whatever I cannot measure, I take it as a circle or oval. Simple. Okay, that is how I need to draw in the diagram. So this is how it happens. So you see here, these are two categories again, reflective measurement and formative measurement. So this is latent variable, and so this variable reflects these variables. And here if you see formative way, so these variables form this way, latent variable. So x1, x2, xk I can measure. So it is in the rectangular square. This I cannot measure directly. So it is in the circle. Same way here, these variables I can measure. So it is in a rectangle or a square. This I cannot measure directly. So with the help of these variables only, you can measure latent variables. Again, the example here, disease. So if you have disease, what all will happen? What all you will reflect? Body temperature you will reflect, blood pressure may happen, pulse rate may differ, pain feelings. Okay, and this is effects. And then comes causes. What all can cause disease? Eating habits can cause disease. I might would have got a food infection. Drinking habits, smoking habits, or by working habits. Okay, so this is how one is reflective way, one is formative way. Other terms which we use in that structural equation modeling, error. Error means what we could not measure again. Okay, what has been left. And then disturbance, variance left over after prediction of a factor. So error and disturbance both are basically errors only, which we could not measure. But error is basically attached to the measured variable and disturbance is attached to a unobservable variable. That is the simple difference. Okay. Exogenous variable, variables that will predict other variables. And if what is endogenous variables, a variable that is predicted by another variable. So if I'm talking about how happy you are with the service quality of this particular hospital, I'm talking about exogenous variable. Okay, so because this particular variable will help me to predict the value of service quality. But when I'm talking about service quality of a particular hospital, I call it as endogenous variable because this variable will be predicted or determined or measured using another variables, not directly. Clear? Direct effect, indirect effect. So regression coefficients of direct prediction. Okay. And indirect mediation effect. So indirect x to y, but if it is going through x to z and then z to y, that is indirect. Directly they don't affect each other. Let us say two friends, they are angry with each other, don't talk to each other, but they talk to each other through a third party. So that time I call it an indirect effect. The interaction is still happening. Okay, so once interaction happens directly and another way interaction happens indirectly. So in this case, indirect interaction happens through a third variable. That is indirect effect. Okay, and this is something more about examples. If you see predictor variable, so moderator variable, if I say, and so how outcome variable will be there. So predictor variable will define the outcome variable or will help us in getting near to outcome variable, and then predictor variable where it will so direct effect, indirect effect, you see that predictor and outcome variable, they are interacting with each other directly and they're also interacting with each other through a mediator variable. So both the ways they're interacting. Okay, it's the same case. Complicated relationships, you can talk about it. So these two people know each other directly, they're talking to each other, and sometimes they're also talking to each other through this third party. So their behavior changes when the interaction happens in indirect effect, their behavior changes. Okay, the student teacher relationship, if you take for an example, so teacher and student, they meet every day. So student will behave with teacher in a certain way every day in classes or whenever they meet in the campus. But let us say one day parents come to school. So in that case, a student behavior suddenly will change in front of teacher. That student will not behave same way, the way he was or she was behaving earlier in front of teacher. The entire behavior changes. So in that case, it is mediator variable. So parents are here mediator variable. So in their presence also interaction is happening between student and teacher, but now indirect effect has also come into the picture. So we have to analyze the complete equation. Okay, we can't ignore the presence of parent here. We have to analyze using that only. There are certain studies where our guide or our co-researchers, they suggest that in this study mediator has to happen. What is the reason behind it? Because if you don't take into consideration the role of mediator, your study is not completed. That is why some studies you have to have a role of your mediators or moderators. Okay, so that is how it happens. And then another thing is measurement model and path model. Before I actually go for the data sheet and show you the practical part, I'm just telling you all the terms which we use there. Okay, measurement model. So measurement model basically the part of model that relates indicators to latent factors, and the measurement model is the factor analytical part of SEM. So it simply will have one-sided arrows, and it will tell you clearly that who is affecting whom. And it is kind of factor analysis, graphical representation, nothing more than that. Okay, which variable has how many factors. So it will come in a picture format. And then path model, path model will basically define the relationships. Okay, which variable is related to whom. So you will be using one-sided arrows when you are defining those path. So that is how your path model will be shown. Done. So this is how it comes. You just spend a minute here analyzing this diagram, and then we proceed further. So you see the difference here. What is the basic difference between measurement model and structural model? When we are presenting in our PhD or research paper, we need to have both. So measurement model, factor 1, 2, 3, 4, and how many variables it is having in between it, and that's it. There is no path. Who is impacting whom? Who is influencing whom? Nothing like that has been told to you. But if you see structural model, clearly paths have been shown. So factor 1 influences factor 3, and this factor influences factor 4. Like that, a diagram has been made. So relationships are clearly defined in a structural model. This is your final outcome model. Okay. And then confirmatory factor analysis, I've already told you. Covariance. Covariance is nothing but based on variance and covariance. So covariance are attached again with the error part only. Okay, how much difference it comes, whatever part you could not measure. And mean structure. Mean structure I'll show you during the diagram. At covariance and mean, both I will show you when I show you the diagram. How do we draw it and what it means actually. Okay. And this is again, I want you to spend a minute here and just try to see what all it means. So each shape has a unique meaning, and that shape only we can use. So you see that as I told you already, square or rectangle, observed, measured, indicator, reference variable. Okay, circle or oval, unobserved latent variable, factor or construct. One side arrow, it depends, it will define direct or path, okay. And then two-sided, non-directional, bidirectional association or correlation or covariance. If you see this E attached with this square, this means measurement error, okay. Error attached with the observed variable. And if the error is attached with this circle or oval, in that case it is known as disturbance error. Okay, so this is measurement error and this is disturbance error. Measurement error is attached with the measured variable and disturbance is attached with the unobservable or latent variable, which we cannot measure directly. Okay, and then this is how a path diagram looks. So you see factor 1 is comprised of 3 variables. Factor 2 is again comprised of 3 variables. Each measured variable is attached with error, because whatever you are measuring, there will be little bit error left. Little bit information will be left which you could not capture. That is why everything is attached with one error variable. Okay, so whether it is measured or it is unobservable, every time error is attached. So you see here, everywhere error is attached. So IND indicator, okay, error. Okay, this is how a path diagram looks. When you are using one-sided arrows, I call it as a path diagram. Okay, and then what are the limitations? It is only applicable when you are using confirmatory factor analysis. So for that, you need to have an already established theory. Then only you can use CFA. Okay, you can't explore actually new things using SEM. It is only for verifying the already established things. If you want to use new theories, explore new factors, you have to use EFA. That is exploratory factor analysis. Okay. Biggest limitation is the sample size. It needs to be large, and to get stable estimates of the covariance or correlations. 200 subjects for a small to medium sized model, and minimum of 10 subjects per estimated parameter, which means that in your questionnaire, if you have one question, for that you need to have a sample size of 10. So if you have 100 questions in your sample, you need to have a sample size of 1000. This is a thumb rule, and little bit here and there we alter it as per the our study requirements and the availability of sample. And it is also affected by size, effect size, and required power. Okay, then comes missing data. So missing data can be dealt, again you have to go to SPSS and you do the cleaning of data, arrangement of data, and you fetch that sheet into SEM for analysis purpose. So SPSS already we have covered, and how do we identify missing values, that also we have seen. And most SEM programs will estimate missing data and run the model simultaneously. And no outlier should happen, and data should be normal, which is the same case for most of the types. Your data should be normal. Okay, then only it supports, then only it gives you better results. And there should not be multi-collinearity actually. So what is that? That also I will explain you. Again, linearity, no multicollinearity, and residuals, covariance, and all that. The multicollinearity concept I would like to define here a little bit, because what happens that multicollinearity is a major problem in SEM. I gave you the example of 20 friends going for a trip, and then those 3 groups we are forming, or 4 groups we are forming in that. So in that case, what happens? You have divided those people in on the basis of their interest levels. Okay, so let us say 6 people are in one group, 7 are in one group, and again 6 are in one group. So why did we divide them into those 3 groups? Because those people were showing similar interest to each other. That is why. But now what happens that group 1 people, out of those 6 members, 2 members are showing extreme inclination with the group 2 members. Okay, every time they are leaving their own group and they are joining another group, and those 2 people of group 2 are again So they also do the same thing. What they do is they go and they also do the same thing. So in that case, what they do, that group 2 you have formed, and then again 2 people, they are also hanging around with other groups. So in that case, it actually makes it difficult for you to organize that group, correct? Because you have formed those groups based on their similarity interests. So in that case, multi-conarity, which means that I am showing interaction within my group also, and I have high inclination towards group 2 or group 3 also. So in that case, neither I'm fully in group 1 nor I'm fully in group 2 or 3, correct? So that creates disturbance. So that is why multi-conarity should not happen among the variables, okay? Or it should not be there at all, or at very minimum level, which could be tolerated. If you take more very high multi-conarity, in that case, your entire structure, your factors, correlation, relationships, everything gets mismanaged, or it will go haywire. So nothing will come in your hand. So entire purpose of doing factor analysis or grouping the variables will not solve the purpose if multicollinearity exists. Okay, the same example you can take here. I have divided 20 people into 3 groups based on their like-mindedness, but again, now they are not hanging around within their group only, they are hanging around with other groups. Then what is the point of forming those groups, correct? So that case, factor analysis entire existence only goes. So that should not happen. So multicollinearity is highly dangerous when you are going for structural equation modeling. That should not exist at all. Okay, so for that, what we will do, we have to correctly organize the variables. Correctly, we have to do the factor analysis test. And then comes a residual. So let us see, error should be as small as possible. Okay, and covariances are being estimated better than others. So that also we'll see how we estimate that. And this is how research should be conducted if you are applying structural equation modeling. So structural equation modeling, if you apply, so in that case, you have to have literature review, theoretical basis, and for that you can have interviews with practitioners and model development. And this will help you to specify your model. And then you need to specify the constraints to obtain a unique estimate of every model or parameter. So in that case, you need to have model identifiability. And then you go for model analysis, evaluation, representation, reporting, and replicating results. So all that you can do using exploratory and CFA. And fit indices will help you to define your model. Okay. So this is how interface looks. I will show you the practical thing also for that. Basically, this is how the window looks. Okay, when you open the AMOS software. So you can open file, you can edit it, and you see here. So first one, all that I'll show you on the actual window only. Okay, and so EFA versus CFA, as I've already told you in detail about it. EFA is you are exploring factors and you do not know how many factors will come out. But in CFA, you already know that how many factors exist, and that comes from review of literature. So EFA basically potential number of factors ranges from 1 to the number of observed variables. Let us say you are having 14 variables when we conducted factor analysis in that case. So when we are having factor analysis for 14 variables, in that case, I may have one factor only where all the 14 belongs to, or I may have 14 variables or 14 factors also. In that case, simply, let us say I'm taking 14 people for a trip. I want to divide them in a group. I ask them, okay, all of you divide yourself into groups, and nobody responds. They tell you that, no, we don't want to divide ourselves in a group. We are 14 people and we all will go together. We do not have any, we don't want any subgroups. Okay, so in that case, only one factor is there. So all the 14 variables belong to just one factor, correct? Another scenario, when you say that 14 people and none of them wants to be together with anybody. So in that case, what happens? all 14 people will will hang around different. None of them are together with each other. So in that case, I'm having 14 factors. So the moral of the story remains same. Still, I need to handle those 14 variables. So none of the situation is advisable for me as a researcher. Neither I should have only one factor, nor I should have 14 factors if I'm having 14 variables in my hand. Correct? So that is how it should happen. So we need to collect data wisely for that to avoid such kind of problems. And if you see CFA features, it is confirmatory, number of factors, pattern of indicator we know well in advance. There is nothing to explore about. Number of factors and observed variables that load on the each construct are specified in advance of the analysis. Everything will be just drawn prior to the data analysis. Okay. And then each indicator is represented as having two causes. A single factor will be there, which you will be measuring, and other unique sources. All the structures basically we are measuring here, we are analyzing here. It will also analyze variance, covariance matrix. So everything, all the error parts, everything clearly will be given to you with the one click away. Okay. And then if you see the clear difference, CFA models fix cross loadings to 0, and EFA models may involve cross loadings of indicators. In EFA model, errors are assumed to be uncorrelated. CFA models, errors may be correlated. Errors may be correlated means they might show interaction mutually also. Okay, errors of different variables, there might be interaction among those as well. So again, if you want to evaluate or you want to have use of CFA, so in that case you need to also have little bit test regarding construct validity, convergent, discriminant, all that we can do to have a robust reliable structure when we are going for structural equation modeling. So I want to have should have a look here. These are the few fit indices which actually comes when you run structural equation modeling. So one is chi-square. So cutoff value, most of the cutoff values are like this. For this we have p-value is more than 0.05. Okay. So it will help you to assess the overall fit and discrepancy between the sample and fitted covariance matrices. Adjusted goodness of fit. Okay, GFI is the proportion of variance accounted for by the esteemed population covariance. So like this, GFI and then NFI, CFI, RMSEA, RMR, ABE, and all that have their own importance. Okay, it is also I have mentioned here why and what they measure. So in that way, they are different parameters to tell you how good your model is. Okay, so that's how it happens. So you can take a minute and spend here. Any queries you have regarding this, you can post in chat box. And if your question is like that which one is best, no, I will not tell you that which one is best, because each parameter has its own importance in the model. But the one thing is I can tell you that if one parameter is good, there is high probability that others will also fall into the place automatically. If your chi-square and GFI is coming into the permissible values, high probability is there that rarely you will not have that kind of misfit. All other parameters will also fall in place because they move together. And that's how it happens. It cannot happen that your GFI is 0.9 and your RMSEA is 0.01. Like that, it won't happen. Okay, that is they will move together. Very small differences will become. So if one is 0.8, another one can be 0.65 or 0.7. Not much difference will come. Okay. So this is how the serve call model I was talking about looks. So it has service quality, which you are measuring. So we already know service quality model. Okay, how many questions are there? Okay, so that all we know. Total 21 questions are there. 5 dimensions will come. Okay, tangibility, reliability, responsibility, assurance, empathy, and this is a satisfaction. So again, the satisfaction will also have an impact on service quality. Okay, so this having 4 variables. So this 21 we don't need to do anything about it. It is fixed. It comes like this only. So this structure I talk about. This is CFA. I already know how service quality structure looks like. So in that case, I don't run EFA. Okay, I already draw this model and I just fetch the data and just done. Get it done. Okay, so and then little bit more complicated if you want to see. Okay, so in that case, this is how it looks. And then I'll take you to the data sheet now. Structural equation modeling. So give me a second. I'll just show you the AMOS interface, how it looks. By that time, if you have any questions, you can post in the chat box. I'll take them also. So I'll be showing you the model of web qual. Okay, this is a commonly used model. What all the parameters are there and how structural and measurement model looks like. That also I will show. So by the time that sheet I'll be able to share you, I'll just take few questions. Slides we'll be emailing you post sessions. Secondary data to run SEM analysis. See for SEM, if you are running it on financial data, let us say you have taken a data from moneycontrol.com or you have taken Sensex data, and in that case, you already know that how it behaves. Let us say BSE and NSE. If you see the correlation between BSE values and the NSE values, it shows you perfect correlation, isn't it? If you have ever tried to calculate it, you take everyday levels of BSE and NSE and you just try to calculate correlation. So you will have more than 0.99 correlation between them. In those cases, you can take it. Secondary data when already the review of literature established and it supports you. In that case, you can always take it. There is no problem with that. Any other questions are there? You can post in the chat box. Okay. We do factor analysis first order and second order CFA. See, when I am only having one factor and it is comprised of few variables, I call it as a first order. When I have the one factor and one factor which is influencing another factor, okay, like that, if I'm measuring, I call it as the second order. Okay. AMOS is not free. Okay. PLS. Yes, PLS you can actually use, not a problem, but that is not the replacement of SEM. Okay. Mediating and moderating variable. This is a very nice question actually. Mediating and moderating. Moderating means that in that variable presence, your behavior changes. Okay. How it happens? You think of any scenario where let us say a very common example we use to define this moderator. Husband and wife, they stay together every day, they interact to each other, and that's how they talk. But when anybody comes to their house, their behavior changes. They don't speak to each other the same way which they were doing, isn't it? Whether they're in-laws, or it is a neighbor, or it is a guest, or it is a friend, or it is a colleague, their behavior, their tone of interaction changes. The way they sit, the way they call each other, it changes. Okay, so that is how this moderator is influencing both the variables and their interaction with each other. Both of them were interacting earlier also. Now also they are interacting directly with each other. But the way they are interacting now with each other has changed. Correct? This is moderator, who influences the direct interaction of the variable. Then comes mediator. Mediator means who will intervene in your interaction. So let us take an example of child. So husband and wife again interacting to each other, but in the presence of child. So child will mediate. Okay, child will intervene in their discussions. So that is how the discussion and the interaction between both of them will change, will be influenced. Correct? So this is how mediator and moderator thing happens. Moderator will not have any intention to influence you. It is happening automatically. Moderator has not told you to change your behavior. Yes, but you have changed it. But mediator is intervening. Mediator is telling you to change your behavior. That's how it happens. Let us say lifestyle. So lifestyle always tells you to change your shopping decisions, isn't it? That is mediator variable. It's not moderator. It is mediator. Because every time lifestyle will tell you, this is how you should shop. Okay. Let me see that if I'm able to show you the sheet now. And then the next question is about scale construction. Can I restrict my work till EFA without CFA? Scale construction is itself is EFA only. Scale construction cannot be a CFA, because when you know CFA, in that case you are not exploring any new scale. You are using old scale itself, correct? You are not exploring anything new in that case. Okay, then comes we do factor analysis using SPSS. We do the same thing in SEM. How it is different in AMOS or in SEM, you are not doing factor analysis. You are just arranging those factors the way you have explored them or the way you have confirmed them, both the ways. So you don't conduct factor analysis, you represent it. Okay. Examples for mediating and moderation, I have already explained you. Okay. And then comes mediator variable. Mediator variables are intervening with the variables also. Yes, they do. Okay. Yes, our studio link again, it will be sent to you today also. So this is how it is. Any other questions if you have, you can post in chat box. So any other question? Okay, yeah. Latent variables, as I told you, latent variable is nothing but which you cannot observe directly. Okay, that is how we define the latent variable. As I have given you the example of service quality. So service quality, we measure service quality using different 20 to 30 variables. Okay, 21 variables which I have shown you. So if you want to measure service quality, you have to use that. Otherwise, you cannot measure service quality. That is how it will happen. Okay. So I'll show you this web qual model also in this AMOS if Zoom supports it. Okay, so I have in which circumstances and situation we can use the ACM and which are the prerequisites for the same. Prerequisite, you need to have your data collected and you need to have a scale used in your study, and you need to define path, okay, using your review of literature or something like that, that how you are going to define it. That is how only you will be doing it. Other than that, you just need a AMOS software and you can have a trial version of it, and otherwise in your lab or somewhere you will find it, or you can buy it. So that is the last option which can be done. Difference between theoretical and conceptual framework or model. Theoretical and conceptual framework, it is kind of similar only. Theoretical or conceptual framework, basically when you have done thorough literature review, after that you come out with a new kind of association. Okay, so in that association, basically it happens that you kind of figure it out how they're interacting with each other. Let us say you have taken different values for in that interaction, how it is actually happening. So let us say you are studying attitude, you are studying perception, you are also studying loyalty. So after that, after some point of time, you will kind of thinking that can I connect these variables in a different way, or any kind of other okay. So likewise it happens. Replacement of AMOS of PLS you can use in some cases, but not much. Okay, there is no free link for AMOS which I can give you. COVID-19, you have developed a questionnaire to know for the public perspective to use of herbs and spices in their diet, and you have got 218 responses, and you need to use a statistics, means which tool is good and effective. Public perspective for the use of herbs and spices. So you can you can actually, how many variables you have in your study, accordingly you can go for factor analysis, and you can come out with the factors which are influencing that choice or what the perspective. So which are the important factors which are framing the public perception for the usage of herbs and spices. Okay, so that way you can deal with it. You can post your questions. I'm just sharing the screen for showing you the AMOS. Okay. Link SEM with factor analysis. See, factor analysis you actually do not need to conduct when you are actually doing it. In that case, you don't need to conduct the factor analysis. As I told you, CFA will do the needful. Okay. Correlation regression analysis after factor analysis. Yes, on those factors you can run your correlation and regression. And open source software for AMOS, no, there is nothing like that. And any other interval scale except temperature. So as of now, zero temperature only we have come out, and I do not think that anything else we have we know about like that. Is it visible to you, Amos? No, I think so. Yeah, now I think it should be visible to you. Yeah, just give me a second. Is it visible now? One of you can give me thumbs up. So this is how our AMOS interface looks. So what you need to do is you can just draw your diagram according to the requirement. So this is how AMOS looks. So whatever you want to measure, you include there. So I'll just take a very simple example here. If you want to draw, let us say this is how you automatically use it. Okay, draw a latent variable or unobserved or observed, whatever you want to have. Okay. So I'll just show you the web coil model also. So I hope it is visible now. web call model was visible to you or not? Rohit, can you confirm? Okay, fine. So this is how it looks. This is measurement model basically. Okay. Sorry, structural model. So in the structural model, we have defined this path clearly. So all the variables, so you see here usability, information quality, okay, and service. So these are three factors. Totally, all these are questions which we have measured. So usability can be measured not directly using these statements. Similarly, information quality can be measured using these, and service can measured using these, and then overall satisfaction can be measured using all these three factors. So like this. So this structure represents basically your entire equation. Okay, all the path, whatever you have defined, this is how you will measure it. And then how do we draw a model? Very simple thing it is. Okay, I hope it is visible to you. How do we draw a model? So you can choose any thing from here. Let us say this is one variable, and if I want to draw like this, so you just select it, and this is how you can draw. So automatically it will come. So this is one latent variable. Okay, and then lot of controls are there. You want to define a path, you want to have a unidirectional, okay, and bidirectional, in that observed, unobserved, and then you want to attach error to it. Okay, so let us say I have taken it a latent variable, and I want to attach an error to it. So this is how I just attach error. Okay, if you want to cut it, you just use this symbol and you can draw it, you can cut it. Okay, and if you want to have the same thing again, duplication, so in that case same thing can be drawn again. If you want to move it, that is also applicable. Okay, so you can move it here and there. And then this is touch up. If you want to correct your drawing, let us say like this, so it helps you in having better visibility. So these are the tools by which you can do it. And whatever drawing you have done here, you just select a data file and then you just fetch it, drag it, and then it is done. Your entire data will come into this diagram. So first of all, you need to draw a neat and clean diagram of your variable, the way you want to present your research. Okay, what you want to measure. That's how you have to do it. So again, zoom in, zoom out options are there, and then undo, redo. Okay, and then if you want to copy it to your clipboard, that option is also available. And then these two buttons, if you press, you will be seeing your entire result. So if I go back to my structural equation model, this is ready. So if you press this button, okay, select data file, which already we have selected. So whatever SPSS file you have, you can import it. Okay, and it will be done. Then next thing comes as calculate analysis properties. So here you have to do some settings. Whatever you want to see again, you can just select those things. So in estimation, you want to have this will come by default, and then numerical output, what you want in output. So all that you can select. So in output, you want test for normality, You want a squared multiple correlation, sample moment, modification indices, and anything else you want. So that's how you select as output. And then the last one comes as calculate estimates. So once you calculate it, your entire result will come in a click. So it just takes some time to generate result. So once your results are done, you will be able to see it. So this shows the values here, and this is how, if you click, you will be seeing all your results. So all the factor loadings have come here, as you see. Error estimates, all the values have come here, and this is the AMOS output window. So you can see the entire, all the values for all your statements. So this is your path diagram. If you want to show the, if you want to see the tables, you can click here. So all the tables will also be visible to you. So whatever results or values you want to see here, you can see that. So any questions you have, you can post in chat box now. I'll just answer those. Interpretation of result, I have already, I shared a slide with you guys that how we can interpret results. Okay, in the beginning only I've shown you that AGFI, GFI and all. So that is how you will be able to see the results in that case. If you want to see the AMOS output, that also I'll show you. So this is how AMOS output is visible. Once you click on this button, it takes little time to generate the result. So view text if you do. So this is how it will come, and there various sections will come. So chi-square value has already come, and the significance level has come. Degree of freedom has also come. So it's just still it is a loading process. So this is how see the entire table has come here. Now whatever you want to see, let us say you want to see the model modification indices, or sorry, model fit we want to see. So we can click on model fit, and all the statistics whatever we have discussed will come. So I just click here on model fit. Okay. See, model fit has come now. I hope it is visible. So your all the fit indices have come. Okay, chi-square minimum, RMR, GFI, AGFI, BGFI, CFI, and what is what, which is important. So if you want to take that PPT which I've shared with you, I have already listed there the important ones. Okay, so everything you don't need to take. This is the entire output thing. You just need to take it. So your basic job is to define your model, doing the thorough literature review and fetching those variables and drawing your model correctly. Okay, so 90% job is done, and then this is just one click away, your entire result comes. It is not like that your SPSS where you need to press individual things where only that you will be able to see the result. Okay, with a single button you press output, the entire output comes, and whatever output you want to take, you can take from there. Let us see assessment of normality if you want to see. So that also comes here. So what is the value of kurtosis, skewness, everything has come here. Okay. So this is how it looks. Estimates if you want to see. So in estimate, so this is how estimates have come. Standard error, label, okay. And this path thing also they have shown who is connected to whom. Okay. So like this, it is all visible. So SPSS be mandated to install first for AMOS to run? No, AMOS will support your CSV files also, Excel files also. So if you don't have anything regard like you are only purely going with CFA, in that case you don't need SPSS. Okay, but if you are going for exploratory factor analysis, and in that case you need SPSS as well. And what is the meaning of value one? That is regression weight which we have given to each variable. Otherwise it won't run. Okay, PPT will share, and yes, latent variable will come from a literature review only, which variable you are going to measure. So that comes from there only. Any other question? So I have covered this thing in brief because everything, all the commands of AMOS we can't do in this much. So what we have to do now is that you can draw your model basically in interface, and then you just need to fetch those variables from data sheet. Let us say you have 10 variables. So you just draw those 10 squares on that interface and connect it to that variable. drag it from your data sheet and run the model. Simple, that much only. So that only has to be done. Other than that, your output window and wherever you are making errors, so that is again one beauty of SEM. It will tell you where you are making error. So let us say you have not assigned a path, or you have not assigned regression weights, or you have not named the variable, or the name is different in your data sheet or name is different in the diagram. It has to be same. Let us say if I call it as quality, so in the diagram also I'm naming it as quality, and in data sheet also I'm naming it as quality. If it is different, it will not be able to fetch it. So like that, it has to be there. So it comes with the practice. So first of all, I need to practice with the drawing thing, and then data fetching, and then we can work on the output. So this is how it comes. Any other question? Yeah, PPT will email you, and today you will again get that link for R. As we have told you that for tomorrow's session, you need to mandatorily install that for better understanding. Otherwise, you will not be able to work with the resource person. So please install it today only before coming for the tomorrow's session. And I hope all of you have filled the attendance form. Okay. So Rohit, we can end today's session.
All right, ma'am. Thank you so much. Dear participants from every single nook and corner of the world, thank you so much for taking time off your busy schedule and joining us for this lovely interactive session on data analysis using AMOS and SPSS. I'm sure you all are taking back home with you a lot more than what you actually knew yesterday, and you will take home a lot more tomorrow. So don't forget to join us tomorrow, and we look forward to welcoming you all. Stay safe and stay well. And we look forward to seeing you all tomorrow. Good evening to all of you. And the ones who are joining from across the globe, wishing you a wonderful day ahead. Thank you again for joining in. You've been a lovely audience throughout. And
thank you all.
Heartfelt thanks to our resource person, about anyone for making this session so wonderful. So I'm sure Dr. Varsha, the entire group of participants out here have had a lot to learn from you. And in fact, even I was listening out, and there were a lot of key points that I personally made a note of it in my own book. So thank you so much, ma'am, for this wonderful session. Truly appreciate it from all aspects. Thank you.
Thank you, Rohit. Thank you all, and we hope to see you tomorrow on time. 3 o'clock we start tomorrow again. And please don't forget to download those links, R and R Studio.
Yeah, participants, 2 more minutes. We'll just keep the session on in case if any one of you haven't filled the attendance link for today. It is mandatory for you guys to fill it up. And also attending tomorrow's session completely will entitle you for your certificate. So please do not forget to log in tomorrow and attending the session, post which your certificate will be issued to you. All right. So thank you once again for joining in.